Welcome to all. Right now we are in the moment of inertia. So many questions are solved, few more are remaining. So if you remember, throughout this moment of inertia calculation, you are using, parallel axis theorem. I about any axis equal to Ig plus AH square. This is very thoroughly explained earlier many times. But I thought series of classes are over. So in between now, just brief reminder. You can call it as either reminder or recalling or some refreshing. Sometimes you tell refreshing or revision type. Today I will tell briefly about this one once again, so that after what happens is series of questions are there. In between, sometimes doubt comes when I write the term Ig. So this is for moment of inertia. This is a reminder or brief reminder for moment of inertia about centroidal axis, that is Ig in the parallel axis theorem. I about any axis equal to Ig plus area into h square. Once again briefly, parallel axis theorem. I about any axis. It can be anywhere. If you want I about any axis, first what you require? First you require Ig, moment of inertia of the part considered. You divide the given area into so many parts, then part by part you are calculating. So whatever you consider, part consider means whatever you are considering, part considered about an axis passing through its own centroid. Own centroid, what I do? I always use symbol own centroid small g. Own centroid, I always use small g. Color problem, okay. I put a lot of ink there, that's why. Okay. Sometimes these things I cannot do anything. Okay. Passing to its own centroid, but it should be parallel to required axis. Means that axis passing through moment of part considered about an axis passing through its own centroid and parallel to required axis. A is the area. H, perpendicular distance from centroid of the part considered, this one G, to the required axis. We applied many times, just a revision type now. Now, what you have to do is, I will tell once again now. There are two important notes are there. I will tell now only. One note now, right now, one note. Note 1. This is regarding H, where H also is discussed. Suppose you want I about this axis, you write here, or I about this axis. For a part, some part you are considering randomly. This is centroid of the part, G. This area is A. If I want, for example, I will tell random name here, AB and CD. It need not anything, AB and CD. See here. Now, if you want I about AB, what to do? First, come to centroid. Imagine an axis passing through centroid but parallel to AB. This axis. So, equal to Ig. Ig means, here, about this axis. Ig plus this area into from centroid G to AB, perpendicular distance. This is H from G to AB. HAB square. HAB square. Now, make a note, this is told so many times earlier. Perpendicular distance. So, whenever your moment of inertia is about a horizontal axis, the squaring is for vertical distance. See, whenever you want I about horizontal axis, squaring is for vertical distance. Whenever, same way, see, suppose you want I about CD. See, right here, somewhere here, space is there. See, I about CD. What you do? First you write IG. IG, color change here, no problem. IG means what you have to do? If you want I about CD, this color confusion. First come to centroid. Imagine axis passing through centroid parallel to CD. See this axis. The IG, this IG is, say I'll put here now, this IG is about this axis. About this. See, don't see this one now. See, if you want I about CD means about this axis plus area into h square from centroid to CD. See, h from centroid to CD, h CD square, h suffix CD whole square. Okay, this is reminder. So here one reminder is that if you want I about any horizontal axis, see, I'll stretch the hand now. You go to the component, go to its centroid. Imagine an axis passing through its centroid parallel to this axis, means horizontal axis. Write I about that axis, that is your IG, plus area into axis horizontal means perpendicular is vertical. Vertical distance square from centroid to AB. If you want I about any vertical axis, see here. First go to the component. Come to CG. Imagine an axis passing through its CG parallel to this axis. So vertical axis parallel. Write I about that axis, that is IG, plus area into this distance square. Vertical axis means horizontal distance square. This is one reminder. Okay. Now, there is one more reminder is there. I will tell you now. This I told many times earlier. I will tell once again. See. That is second reminder, second note. Then I will go for all standard cases. Once again. Red color I am writing note 2. Note 2. Red color I write. See. When we consider, see. When we consider IG, for a rectangle or triangle, any type, right angle, triangle, or whatever you want you can call, some triangle, that we will discuss later, any triangle, then in IG, you will have, what will happen is, one dimension, one linear dimension, you will have IG in the form of base into height cube divided by some number will be there. Number I will change later, number. Okay. Number we will discuss second round. Now, this I will tell last time. Rectangle or triangle. Base into height cube divided by something. Rectangle is divided by 12. Triangle usually 36. But one special case 48 will come. That we will discuss later. Whatever it is, see, base into height. Here, base is parallel to axis. So therefore, the side which is parallel to axis is as it is. No power. If it is 200, that's all. Write as it is. When you want about a horizontal axis, horizontal side as it is. When you want about vertical axis, vertical side as it is. And height is perpendicular to base, or it is perpendicular to axis. Why? because base is parallel to axis, height is perpendicular axis. Therefore, height will be always, see, and in the term for IG, that height will have power 3, that is cube, or I will tell red color now, side which is parallel. Lastly, I will tell. Next, I will not explain. Side which is parallel to axis. Parallel to axis as it is. As it is. And cubing. Cubing is always for height, I can call for side or height or some dimension, anything, some dimension, okay. Rectangle you call side only, okay. Cubing is always for the side or height or dimension which is perpendicular to axis. Perpendicular to axis. Now I will dictate. See, I will dictate. Lastly, I will tell you write it. If you want I about horizontal axis, horizontal dimension as it is, vertical dimension to be cubed. Same way, if you want I about a vertical axis, vertical dimension which is parallel, see, the dimension which is parallel, vertical dimension as it is, and the horizontal dimension to be cubed. Okay, now I will not tell anything about it in future. See, these all I am telling in very simple language. If I talk technically, people will have difficulty. So that's why I don't talk too much technically. Not that I cannot talk. No, I know limitations. Simple way told only, people get confusion. So these all go through. Now I will start standard cases one by one in correct order. One second round, last round for reminder. Now, I will dictate something, you should write. See, standard cases. Red color I am writing only one important, rectangular section. See, what you remember is, see, this is B, this is D. You should write if you want, seriously, if you understand. We will tell B is the breadth, D is the depth. Because usually people will tell horizontal side as breadth, vertical depth, but don't by heart. B and D. Then centroid is here, G, exactly midway. See, if this is B, see, B by 2, B by 2. If this is D, D by 2, D by 2. And if you want area, it is breadth into depth or multiplication of the two sides, B into D. Okay, now, moment of inertia you require. Remember, write words. By words, Ig equal to, see, you write by words. Ig equal to side parallel to axis into perpendicular side that is to be cubed, cube divided by 12. Don't by heart BD cube by 12. So side which is parallel to axis, I told already now, side which is parallel as it is into perpendicular side cube divided by 12. So if you want I about this axis, see, this axis, Ig if you want, it is, see, this Ig. I use the color, green color for this one. This Ig is for this axis, parallel is B. So B into perpendicular is D. D cube divided by 12. If you want I about this axis, see, for this axis, parallel side is D. So D into perpendicular side is B. B cube by 12 over. Now, one note right here. Every standard case, this all I gave earlier, second round. I am giving numerical examples. For all the numerical examples now onwards, make a note. All dimensions are in millimeter. I won't write every time millimeter, millimeter like that. Therefore, your I will be in millimeter power 4, area will be in millimeter square, and write any distance will be in millimeter. Not required, right? Any distance you mark. Any distance you mark will be in millimeter. Understood. Now onwards, this is for today's entire class. Okay, start. You make a note. Consider a rectangle of horizontal side 200, vertical side 500. You write that way. Start. See, this is 500. So therefore, this is one centroidal axis. 500 means, see, 500 here. 500 by 2, 500 by 2. 200. 200 by 2. How much is not required? 200 by 2. Area. 200 into 500. Either 200 into 500 or 500 into 200. Area you can do anything. Why? There is no squaring or cubing there. Then, if you want I about this axis, see, for this axis I, if you want, parallel side is 200. See here, for this axis, parallel is 200. So 200 into, and for this axis, perpendicular is 500 cube by 12. If you want I about this axis, parallel side is 500, see, and for this axis, perpendicular is 200. 500 into 200 cube by 12. Sufficient. So one rectangle over now. Now second one is very important. Triangle. Very, very careful. Triangle. Triangle, there are three. Red color I am using for importance. There are three cases. Okay. What I will do is, I will discuss one by one case in order. I will first write case 1. Case 1. I will start from simplest one, right angle triangle. Easiest one first. Right angle triangle. Now, I will write everything, then I will explain. Now, I am discussing triangle case 2. I wrote case 2 here, okay, 2 triangles. There are 3 cases, sub-cases. See, case 1, right angle triangle. See here, this everybody knows. This is 90 degrees. It can have any orientation. I will explain in the numericals. But what you remember is, one of the side we will call base B, other we call height. When you put standard expression, usually horizontally people call B, vertically height H. Okay, that's okay. But don't by heart BH. Okay, now, see, this is 90 degrees. Area equal to half into base into height, half into B into H. Everybody knows. Either half into B into H or half into H into B. No problem. Where is centroid? G. See here. This way, see, this way, there is more area this side. See here. You don't see other things. As you go this way, see here, area increases. More area here. Centroid is always on that side where area is more. So centroid is near to right side as per this sketch. So and distance is 1/3 or 2/3 of the dimension you are moving. So this way 1/3 B, this is 2/3 B. Here, more area this side. See, so centroid is near to base side, 1/3 H, 2/3 H. Or you make a note. You always come to right angle. See this point. Centroid is near to G. See, when you mark centroid here, it is near here. See, if you start from here, from the point where right angle is there, both are 1/3, 1/3. Whereas, see, if you come here, these you can call vertex. See, from other two corners, see, 2/3 and 2/3. Or the 1/3 and 2/3, that is expression for centroid, is only when along the height. See, when you take this as the base, 1/3, 2/3 of height. Or if you take, look from this side, if you take h as the base, b becomes height. Remember that way. This all I explained. Okay, now I already told you. Now make a note. Ig is always equal to, see, base into height cube by 36. Base is parallel to axis. Height is perpendicular to axis. See here, if you take this axis, base, when you want I about this axis, parallel to axis B, base, perpendicular is H. So about this axis, parallel side is B into H cube by 36. See, I wrote here. When you want about this axis, see, for this axis, the parallel side is H. So H into base cube by 36. Okay, this is clear. That is for right angle triangle. I will give right now numerical examples. Fast I will give all orientation for you to understand. See, example, numerical examples. You write here. We are going for now red color is not required now. Okay, I'll put it here. Okay, here. We'll go for numerical example. See, numerical examples. As usual, I told you, for all the numerical examples, dimensions are in millimeter. Therefore, when you mark any distance, it is in millimeter. If you write area, it is in millimeter square. Whereas if you write moment of inertia, it is millimeter power 4. I won't waste time on those one. You should know it. See, I'll give one by one. One here. Subdivision 1. See, what I told just now. See here. Correctly see. Imagine this way. Side required. Randomly I'll write here. Some space problem. I'll remove this one now. You write here. Numerical example. Okay, you write here. Numerical examples. Space problem. Example coming up here. See, 1. Little small I will write. See, this way. I will write dimension here randomly. Say 150 millimeter. Height something 250 over. Not 150. It's not 250. 150 is 150. 140. Okay. Over. Numerical example 2. I will do one thing now. I will put it this way. See here. This side. Don't see that one. 150 I'll put here now. This is 150. Let me have a dividing line here. Dividing line. Okay. See, side here. 300. Numerical example 2. 300 by this height is anything. 300. 240. Okay. Numerical example 3. Here over. Now this way over, this way over, this way. This way, see, everything is covered. This is something like, say, 160. Dividing line required here to avoid confusion. 160. This is, say, 160. 125. Okay, over. Numerical example 4. Correct? One this way, one this way. Oh, yes, everything is covered now. All cases are over now. Nothing pending. See, I'll just check the camera once actually. See, this is small distance, 60. Why small? This is 70. Okay, over. 1 minute. Yes, no problem. Now, I'll first finish the formality. That is to save the time. Area, I'll use a black color only. Area for this one. Half into 150 into 140. For this one, area, anywhere. Half into 300 into 240. For this one, area, anywhere, area. Half into 125 into 160. Formality only. Area for this one. Half into 60 into 70. Okay, area clear. Centroid, see here. Come here, where right angle is there. See, from here, go 1 by 3, divide into 3 parts. Here, see, from here, this way also, divide into 3 parts. From here, go to the first part, see, intersection is here. This is centroid G. See here, so this now, this is 1/3 of 150. Very small distance, see, this is bigger one. 2/3 of 150. If not visible, zoom and see. This one. 1/3 of 140. This distance is 2/3 of 140 over. Here, see, 90 degrees here. 3 parts, 3 parts. This is centroid G. Now, through centroid, draw 2 axes here. We want IG about those axes later. Okay, 1 minute. Now here, see, 1 axis here, 1 axis here. Now, this distance, 1 by 3 of 300. See, 300. This is 2 by 3 of 300. This way, this distance, 1 by 3 of 240, this one 2 by 3 of 240. Okay, hope it is visible for you. Space problem is there here, see, 90 degree here. First, centroid G. This is 1 by 3 of 160. This is 2 by 3 of, see, if it is not visible properly, I am pronouncing it so that no confusion. 125, come this side. Okay. Here, this is the smaller distance. 1 by 3 of 125. This is 2 by 3 of 125. Okay, here, see, 90 degree here. See, first part, G. Near this corner. Centroid is near to this 90 degree point. So this is, see here, this is 1 by 3 of 60, 2 by 3 of 60. Here, this is, see, this way, 1 by 3 of 70, this is 2 by 3 of 70. Okay, now, axis here, its own centroidal axis. Now require IG, most important, see. IG, everywhere I want IG, see here. I want this IG, I want this IG, want this IG, later this IG, I have to put the ink, this IG and also this IG, this IG and this IG. I use black color, right? Writing not proper. Start. This IG, parallel is 150, that's all, see. Parallel is 150, that's all. Then other one is 140. See, first to decide parallel. Write parallel as it is, the easiest way. Which is parallel to axis, write as it is. Which is the other one, perpendicular, cube it. 140 cube divided by 36. This IG, for this IG, parallel 140. 140 into perpendicular is 150. 150 cube by 36. Here see, for this IG, parallel is 300. 300 into 240 cube by 36. For this IG, parallel is 240. 240 into 300 cube by 36. This IG, see, parallel for this axis, parallel is 160. So it is 160 into perpendicular is 125. 125 cube by 36. For this axis, parallel is 125. 125 into 160 cube by 36. See here. For this axis, parallel is 60. 60 into 70 cube by 36. For this axis, parallel is 70. 70 into 60 cube by 36. So now your difficulty for right angle triangle is over. Okay. Now come to second case, isosceles triangle. I write it. Okay, continue. Triangles you are doing, case 2, isosceles triangle. See, B is the base. Usually horizontally you take base, height. You write here. This is base and height. Now, this side should be equal to this side. This angle is this angle. So, if I draw one dotted line here, perpendicular to the base, it will be exactly B by 2, B by 2. That is for isosceles triangle. Now, very important, do not divide into two parts. Right? Reason here, because isosceles triangle, there is no problem. Standard expression is available for moment of inertia about centroidal axis, about both. Problem is for triangle in general. That is, next case 3 is the problematic. Right angle triangle, no problem. So, dividing into part is a waste of time. See here. Centroid. See, this is axis of area, half base into height. This is axis of symmetry. Therefore, this IG, be little careful. One star mark I will give you. Very important. Later I will not explain now. See, centroid where? See, this way, see, half, see, this is B, B by 2, B by 2. But this way, see, with respect to base, height-wise, see, near, see, centroid is this side. 1/3 H and 2/3 H. Okay, area over. Oh, moment of inertia. See here. One centroidal axis here, one centroidal axis here. Now, one note you write. For a triangle, I about centroidal axis is base into height cube by 36. If base and height are clearly defined, see, that is, see now, correctly. Make one more note here. If it is a right angle triangle, see what happens. There is a previous case, see. If it is a right angle triangle, see, this way. I will call B and H. Look this way. This is base, this is height, clearly defined. See, and one more thing, clearly defined. Also, the base should be always extreme edge, very important. That base should not be in between. Make a note. It should not be in between. Then only number is 36. Cubing, I already told you. Parallel as it is, perpendicular to be cubed 1000 times I told. Now see here. Make a note. If I look from this side, see, base, height clearly defined and base extreme edge. Or if I look from this side, height, this becomes the base. This becomes height. Again, base is clearly defined. That's why for right angle triangle, see, I told you, this I is how much? Parallel side is H. H into B cube by 36. This I is, this IG, okay. This IG is, parallel is B into H cube by 36. It's already over, right here. This is already over. Now come here. About this centroidal axis, see here. Base clearly defined, height clearly defined, and base is extreme edge, therefore regular, no problem. Right mark means regular. How much? Base into height cube by 36. But about this axis star, I will dictate something here. When you consider that centroidal axis which is perpendicular to base, or which is axis of symmetry, which is axisymmetry for an isosceles triangle, this is not base. See here, it is a base provided you look one side. Of course, this symmetry axis will divide into two right angle triangles. If you consider each right angle triangle separately, it is a base. Correct, understood. But it is not the base. See, it is not the base. So this is special. This is something special. This IG is, first of all, remember this I about the centroidal axis, which is symmetrical axis for isosceles triangle, where base is not, base is not extreme edge. Right here, that base is not extreme edge. Because somebody will tell, sir, yes sir, this is the base, sir. Yes, but that is not the extreme edge. See, this is the extreme edge here. In that case, once again, I equal to, right here, I equal to, which is parallel first. For this axis, parallel is H. Okay, H. Where is it? H. And for this one, perpendicular is B. That is no problem. B cube by not 36. You write divide by 48. 48. Be careful. This is star. Make this note. This already told earlier, and we even derived it also. Okay, now I'll go to isosceles triangle numerical examples. I'll give 4 numerical examples. So this all I'll remove now. Everything is over. Now don't tell me. You should write each and everything and practice. People still don't understand importance of practicing. Okay, start. Right. For isosceles triangles, numerical examples. Numerical examples. 1. Now red color I will not use now. Red I am not using. Okay. 1. See. Imagine this. See here. Imagine like this. You write here. Let the base be here something 600 out of scale. Let the height equal to some here, see, 400. Full triangle you consider. Area equal to half into 600 into 400. Okay, area over. Centroid. See, one more thing here. See, 600 means they should tell it in the question only. What? These two are equal. Otherwise, it is not out of scale. Okay, I should come. That all you don't bother. Sir, it does not look like that, sir. You make it look like. If you, this is 600 means both are 300, 300 given. Now, centroid. See, where centroid? This way, see, this is axis of symmetry. Make a note. This is your axis of symmetry. So, star will come here. And this way, centroid is here. This distance is 1 by 3 of 400. This is 2 by 3 of 400. Okay. This way set the centroid G. This way is midpoint. Now, this IG is as usual. Why? See, base defined here. 600 into 400 cube divided by 36. Regular. But this IG is, oh, this is not the base. Or even if you take this as the base, it is not extreme edge, it is in between. Oh, in between means, correctly remember, parallel side how much? 400 into perpendicular, 600 cube divided by 48. Okay. Example 1 over example 2. This all you have to make a note. You take like this, see, this way, center, single triangle, isosceles triangle. This full base is 225. It is given in the question, both are 112.5, midpoint 112.5. And this way height, some height required, given in the question, 350. Okay. It looks like a little smaller, 250. Okay. 250. Okay, now, see, full triangle comes here, as it is, isosceles triangle. Centroid G is here. See, this is your axis of symmetry. So star will come. It is not edge, it is an in between special thing. This IG you should be careful. Whereas this IG, see here, this IG is regular. What is regular? No problem. Parallel. 225 into perpendicular is 250 cube by 36. This is no problem. But this IG is, see, this IG is parallel 250 into perpendicular 225 cube by 48. That is star. Star will come here. Okay. Sufficient this much. Now, where I can. Example number 3. See, I am covering each and everything, so nothing is left out. 3. Okay. See, imagine this given, this base is 160. So, also given, these two are 80, midpoint. Therefore, it is an isosceles triangle. Be careful, this is 180, 110. Okay, now, take a single triangle. Dividing is not required. See, this is axis of symmetry. This is axis of symmetry. Centroid lies here. But this way, see, this way is 80, but this way is, this is 1 by 3 of 110. This is 2 by 3 of 110. Now, see, this IG, there is no problem. Why right mark means what? No problem. No problem, because when you want about this axis, the base is clearly defined and base is at the extreme edge here. So, parallel 160. 160 into height is 110 cube by 36. But this IG problem, see, star will come here. Oh, this IG, when you write here, what happens here? See, it is not extreme edge, but it is axis of symmetry. So, parallel side is 110. That is same. 110 into, that is always same. Cube by not 36. 48. Okay. Lastly, fourth example, last example. Now right side. Fourth example. Okay. This is, say, 150. This time little bigger, 240. Okay. Now, and also given, this is isosceles triangle. How you know it? 150 means given, 75, 75. Okay, now, consider full triangle. Now, see, centroid is here. This is axis of symmetry. Remember, axis of symmetry, so star will come here. Be careful. This is centroidal axis parallel here. Now, this is your G. This is 1 by 3 of 240. This is 2 by 3 of 240. Now, when you want this IG, see here, for this IG, parallel side 150 is the base, and it is base and height are defined, and it is extreme edge, so no problem. Direct answer. How much? That is base how much? 150 into 240 cube by 36, usual. But this IG, be careful. For this IG, star will come equal to, see. What happened? That IG only I wrote. No, that IG is same. Okay. This IG, see. This IG is star will come because this is axis of symmetry and this is not the base, it is not extreme edge. So special treatment required. Parallel side is 240 into perpendicular side is 150 cube. This is same format, divided by 48. Okay. 4 cases are over. Now we'll go for case 3. Where is the red color? Here. I want red color to mark it. Okay. Not much time. Case 3. I'll go to case 3. Triangle in general. Triangle in general means neither right angle triangle nor isosceles triangle. Random triangle. You should be very careful now. See. See here. Now, consider randomly. This is the triangle. One example sufficient. See, somewhere here is this way, randomly. See, sir, just imagine this is the base. Base B. This is the height. Okay, now, very important here. If I project this one here, this way, right line, these two are not equal. One of them is bigger, other is smaller. Which bigger, which smaller does not matter. It is B1, B2. Okay, reasonably okay? Okay, I think I should not give too much importance to these things all. Because teaching means, technical teaching is important. B1, B2. Now, area is no problem. What is area? 1 minute, before area, right here. Area, if you make a note here, make a note. If you take entire triangle in a single stretch, area equal to half into base into height. And height wise, see, this is centroidal axis. You make a note here. This is 1 by 3h and this is 2 by 3h, and this IG will be B into h cube by usual 36. No problem. So far no problem. But the centroid, other axis, there is no symmetry here. It will be always that side where length is more. It will be this side. It can be that side also. See, somewhere here. This is centroid. Now, when you want I about this axis, see, this IG is, oh, problem, right here. Note, oh, problem. Means no standard expression. No standard expression. No standard expression. Therefore, what to do? What to do is no other way. Divide the given triangle into two right angle triangles. Right angle triangles. And consider each of them separately. Oh, therefore, make a note. If your purpose is only I about this axis parallel to base, there is no problem. Dividing is not required. But when you want I about this axis, there is problem. And problem means we do not, suppose in a question given where you already solved it, rectangle, semicircle, and this triangle is there. This triangle, when you do one of the axis, you don't divide into parts. But other axis, you divide into parts. So we do not want, right here, we do not want that confusion. Confusion is not for us. That is only for me. I can do it. If my purpose is about the horizontal axis here, I won't divide. But what I do and what you do is different. Or I don't want to tell further actually. Okay, I can tell how much I know, you don't bother. I am coming down to your level. Therefore, right here, therefore, no, 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 no. We do not want this way. We will go for dividing into parts. See here now. What we will do is divide into parts. See, once again I will write here. Therefore, best option is divide into two right angle triangles and consider each of them separately. Then no problems here. Separately. You write then right angle triangle. We are experts. See, in the beginning only I saw. Therefore no problem. So therefore what to do is, see here. This is the triangle. Somewhere here B1. See, divide like this. This way and this way. See, this way. Okay. Now this full is base B. This is B1. Make separately mark B1 and B2. This is height h. Okay, then see, now this, right now two triangles. I will take this, I will take 1, this I will take 2. See, I will put somewhere here. This I will take 1, not there, some space where, okay, 1. This I will take 2. Now, this triangle and this triangle consider separately right here. Then, if you consider separately, this is a right angle triangle. See, 90 degree here. Don't see that side. Divide this into 3 parts. Here, vertically divide 3 parts. This is centroid. G1. G1 is here. Then, one axis here, one axis here. And distance wise, this is 1/3 of height is h. And this is, and this one is, these are 1/3 of B1. This is 2/3 of B1. Here, divide height already 3 times over. Base also 3 times. G2. If you want this distance, it is 1/3 of B2. This is 2/3 of B2. Height wise, it is same as last time. See, height wise same, but right here, height wise once again 1/3 of h and 2/3 of h. Now, if you want A1, it is half into B1 into h. When you want A2 here, half into B2 into h. And for when you want this Ig for figure 1, Ig1, this Ig1. Ig1 means for one this Ig and this Ig, and later when you want, see, where write over here, I write here, okay, this Ig2 and also this Ig2, no problem. See here, this Ig1, don't see that side, right angle triangle, Ig1, B1 into h cube, B1 into h cube divided by 36. About this Ig1, parallel side is h into B1 cube by 36. When you want this Ig2, see, this Ig2, parallel is B2 into h cube by 36. and this IG2 is H into B2 cube divided by 36. Okay, now I will go to a numerical example for this one. One example sufficient because right angle triangle, whatever we get, already we covered earlier. So now just one numerical example for this type. Then I will go for circle, semicircle and quadrant and close. Okay. Now numerical example, two examples I will take up. First one, see, 500, 310, 200 height. Make a note here. This is triangle in general. If you want I about horizontal axis pass into centroid, there is no problem. Vertical axis pass into centroid, difficulty is there, no standard formula. So to avoid confusion, it is better to divide into two parts. Two parts, that is two right angle triangles, say 1 and 2, as shown. See here, one triangle here, one triangle here. Now each of them consider separately. Okay, start. I will take one. See, 310, 200. So, see here, this is right angle here. Don't see that side. See, this distance is how much? 1/3 of 310. This distance is 2/3 of 310. Here, this distance 1/3 of 190. This is 2/3 of 190. For this way, see, for this base height, height wise, three parts. See, you write here, this is 1/3 of 200 there, this is 2/3 of 200, space is not there, okay, right here, 2/3 of 200, even here also, see, same thing, this also is 1/3 of 200, from top it is 2/3 of 200, okay. Now, when you want IG, see here, centroid is here, see, this IG, now it is right angle triangle, see, base, parallel side is base height, 310 into height is 200 cube by 36. This IG, see, this is the base, don't see that side, see only this triangle, so 200 into 310 cube, 200 into 310 cube by 36. This time no 48 here. This IG, space is not there, I register here. This IG is 190 into 200 cube. 190 into 200 cube by 36. This IG, see, this IG1, this IG, IG2, IG for second one is, see, this is 200 into 190 cube by 36. This way do it. Actually, one example sufficient. Why waste time? Okay, over. One example sufficient. Because already this is over. This is a refreshing part. Therefore, one sufficient. Okay, now triangle over. Now go for next one. Circle, semicircle and quadrant. Last round. One sufficient. Okay. Lastly, see, all standard cases. 3 is circle. 3 is circle. 4 is semicircle. At a single stretch I am giving standard. 5 is quadrant of a circle. Quadrant of a circle. See, I will put a single stretch. First, circle, semicircle. Then example, semicircle. Next, quadrant of a circle. Quadrant of a circle. Remember, for all these, to save the time, you write, let D be diameter. Let D be diameter. Remember, for circle and semicircle, you can see the diameter. For quadrant, you have to imagine the diameter. Everywhere, center I am doing a dot. See, circle. Diameter D. Diameter D. Semicircle. This way. Diameter D. Dia equal to D. Space is not there. Quadrant of a circle. Anyway, you can mark your choice. See, quadrant of circle. See, now this is center of the circle. Here, this is center of the circle. Here, center of circle is here. You make a note here. Center is here. Solid dot is center of circle. Here also, somewhere right here. Diameter equal to D. See now. Area. Circle. 5/4 of diameter square. Semicircle area. Half of that area. 5/8 of diameter square. Quadrant area. 5/16 of diameter square. Then, see here, this is the diameter. Here, this is the diameter. You know it. Here, diameter you cannot see. This is not diameter. This is diameter by 2. This also is diameter by 2. You should know it. Because diameter is see, somewhere here. Centroid. For circle, centroid coincide with center. Semicircle, see. Therefore, see the two axes here, centroidal axis, directly. These are the centroidal axis. I want this IG and I want this IG. Okay, then here, centroid, see, this is axis of symmetry. Make a note here. This is axis of symmetry. And it is one of centroidal axis. So this is one IG you want. Other is somewhere here. It is near to this base. See, it is near to the base. This also I told. This is CG. Here, CG, see this way CG is, if this is D, this is D/2, D/2. Directly visible, center. But this way is 2D/3 pi. 2D/3 pi. Here, there is no symmetry. Centroid is here, near to this base and near to this base. Centroid is here. See? Here, see. From center come here. This is 2D. See, from center you have to mark. This is 2D/3 pi. This also is 2D/3 pi. Okay. Now, we want this IG and also we want this IG. We want this IG. Okay. We want this IG. Okay. Start. Correctly remember now formulas. I write black color because that color is not writing properly. And then last round is example. Okay. See here. For a circle, remember, about any axis, it is 5d⁴/64. 5d⁴/64. No confusion. Circle over. Semicircle, if the centroidal axis, what all I am telling you should write, if the centroidal axis is axis of symmetry, yes, so see, this is, then I is, whatever is answer for circle, divide by 2. So, half of circle, see, for semicircle, if that centroidal axis is symmetry axis, answer is half of the I for circle. Circle is πd/64, so πd⁴/128. But this is not axis of symmetry. If it is not axis of symmetry, there is no pi. Diameter power always 4 only. For any circle, semicircular quadrant, it is always diameter power 4. But if it is not symmetry axis, then a decimal number will come. For semicircle, decimal is 0.00686 times d power 4 about this axis. D power 4. Now, quadrant of a circle, there is no symmetry and both are equal, and answer for that also is decimal. How much is the decimal for semicircle? It's half. So, its half means 0.00343 d power 4. This Ig also equal to 0.00343 d power 4. This is standard. See, once again I will tell, circle area pi d square by 4, semicircle area half, pi d square by 8, quadrant pi d square, it's half, pi d square by 16. Okay, then circle any I, centroid is through at center. Any I is pi d power 4 by 64. Semicircle, centroid, see, centroid. There is one symmetry axis. Centroid lies in symmetry axis. So that is exactly center, this way. But other way, it is from the base if you measure 2d by 3 pi. For a quadrant, measurement from center, both are 2d by 3 pi. I. For circle, pi d power 4 by 64. Semicircle, if it is symmetry axis, I is half of the I for circle. Pi d power 64 means by 128. But if it is not symmetry axis, then pi is not there and a decimal number is there, 0.00686 diameter power 4. For quadrant, first of all, there is no symmetry. So, I is again decimal number. And decimal number for that quadrant is half the decimal number for circle. Half of the decimal number for semicircle. 0.00686 means 0.00343. Okay, now lastly I will give numerical examples and close it. This, okay. All I will remove now. Okay. One round numerical example. Little fast I will tell now because there is a limit for everything. See. First, see, numerical examples. Numerical examples. Full I will explain. Examples. First for circle. Okay. Take a circle randomly. Okay. Circle. Imagine diameter is 150. That means this is 150. This also 150. Crystal clear. 150. This is center. Then this is axis. Now area. Area equal to pi into diameter. How much? 150 square divided by 4. Okay, then so this is centroid G. You want I about this axis, this IG. I will change the color now. That green is not writing. This IG. For circle, both IGs are pi into diameter power 4 by 64. Pi into diameter power 4 by 64 over. This is for circle. Now, semicircle, I will put all semicircle, all millimeter. To understand correctly, I will do one thing now. Semicircle examples for semicircle. So that in future, no difficulty. See, one semicircle I will take this way. See, this way. Example 1. Example 2 I will take this way. Example 3 I will take this way. Example 4 I will take this way, so that no confusion at all. Okay, start. This dia, imagine dia is 200. Therefore, this is 200. If this is 200, remember, this will be 100, half of diameter, 100. Okay, here. Area. Pi into 200 square divided by 8. here. Imagine this dia is something 140. So this is 140. If that is 140, this will be 70. Okay. Add area 5 into 140 square divided by 8. Here, imagine this diameter, given diameter is say 90. So this is 90. If that is 90, this is 45. Area for this one. 5 into diameter square divided by 8. Imagine for this one, diameter is 110. So that is, this is 110. So that is, if you want this distance, it is 55. Area 5 into 110 square divided by 8. This much clear. Centroid. See correctly what I am doing now. Axis of symmetry. So exactly midpoint. 200 means 200 by 2, 200 by 2. But this here, see, axis of symmetry. So this is and this one both are 140 by 2, 140 by 2. Here. This is axis of symmetry. See here. This is 90 by 2. I will change the ink now. This is also 90 by 2. Here. This is axis of symmetry. 110 means 110 by 2 and 110 by 2. 110 by 2. Okay, now important, I should go for I about centroid. I do not want to pause the recording. You wait, observe the sketches once again. When I am putting some ink there, you observe everything once again. So that I don't want to pause and restart once again. Single stretch I want it. Okay, now if anything is not a clear blur, I will make it clear now. If something is not clear there. Okay, now this part is no problem. Centroid is more important. See now centroid here. This is another axis. This is 2d by 3 pi. 2 into diameter is 200 divided by 3 pi. Here, centroid is here. This is 2d by 3 pi. 2 into 140 divided by 3 pi. Here, centroid is here. See, this is 2d by 3 pi. This is 2 into 45 divided by 3 pi. Here, this is 2d by 3 pi. 2 into 110 divided by 3 pi. Should be clear. Now, I want this Ig, then I want this Ig, I want this Ig, and I want this Ig. Space is not there, you write neatly. We want this Ig and also this Ig, this Ig and this Ig. See, correct what I am doing. This Ig, symmetry. So, half of circle, pi into 200 power 4 by 128. This Ig, it is not symmetrical, decimal number 0.00686 into diameter power 4. Here, this Ig, symmetrical axis, pi by 1 to half of circle, pi by 128 into diameter power 4. This Ig, this is not symmetry, it's not symmetrical, so decimal 0.00686 into diameter power 4 is 140 power 4. Here, this is symmetry, so half of circle, pi by 128 of diameter is 90 power 4. But this Ig, this is not symmetrical, so 0.00686 into diameter power 4. Here, this Ig, see, symmetrical, pi by 128 into diameter is 110 power 4. But this IG is not, this is not symmetrical. So 0.00686 into 110 power 4. Little fast I am telling because I do not want the class to be too long. It is already over, not once, so many times over. So just a recap. First of all, I should give only one diagram. Okay, now lastly, quadrant, I will write and explain. I wrote everything, actually not required, still see. Diameter 120, imagine. Let diameter be 130. Let diameter be 400. Diameter is 180, randomly. Okay, see. Center of circle here. Diameter 120 means 60, 60. Diameter 130 means, I forgot right here. Okay, somewhere I'll write here. This is 65, 65. Okay. See, 65, 65. Diameter, where is the diameter? 400 means 200, 200. Diameter 180 means 90, 90. Why? Half, 1/4 it is. 1/4 is only quadrant, radius you can see. Then, see, centroid is here, G. Near to this point, see, radially nearest here. Here, radially nearest point, G here. Here, see, radially nearest point, G. From here, G. From here, see, this side 2d by 3 pi, 2d by 3 pi. From here, 2d by 3 pi, 2d by 3 pi, where d is there, here I put how much? 130. Here I put d 120, respective values. Here also, 2d by 3 pi, 2d by 3 pi, 2d by 3 pi, 2d by 3 pi. Okay, now, lastly, IG. I told quadrant of a circle, there is no symmetry. So, decimal number will come. What is the decimal number? Half of the decimal for semicircle. Semicircle is 0.00686. See, both the IG, see, I written here, both IG are 0.00343, diameter 120 power 4. Both this IG, 0.00343 into diameter 130 power 4. Both this, if you want to write separately, both the IG are 0.00343 into diameter is 400, 400 power 4. Both the IG, this and this, both IG, 0.00343 into diameter is 180, 180 power 4. Okay, over. So, that's all. I am concluding now. This is actually already over earlier in one class, long back, where very slowly I explained. Today I have not explained very slowly because it is a refreshing or revision, just so that all these days when you do moment of inertia, somebody will get doubt. He sometime is putting pi d power 4 by 128, same question, another axis have same semicircle, another place is writing 0.00686, then triangle. Sometimes he writes bh cube by 36, suddenly he writes 48. That all clarified now. So it is, even if you understood everything, go through once again. Learning, there is no limit. Okay. Next class, see, today's class, there is no question number. Next class, I will continue with the questions. Actually, yesterday, I could not upload the class. Some problem was there. I was outside. I could not record night time, previous night. Daytime recording, sound problem comes here. So one day I skip. Usually, I never skip. And you can make one thing. I decided right now to upload at the standard time, daily at evening 6 p.m. Then that is when many of the people will be free. Even if they go to office or college, they will be back home. So I decided 6 p.m. is the better. I will decide later if I am changing it. Okay, now this extra class over. Remember, everything is refreshing or revision, or what you can call is some name you can give. Okay. Thank you. Next class we will meet.